sharing my screen. And, oh, this is not your class. This is your, well, this is not what I wanted to start with, though. This is what I wanted to start with. Today's March 31st. Today we're going to review for that test 3 statistics that needs to be done by the end of the day on Monday. Pushed it back to Monday instead of Sunday because I do know that Sunday is the Easter holiday. Hopefully everybody knows that there are no classes this Friday, so I will not see you again until Monday the 5th. Homework 17, which is on finding z-scores and margin of error, is to be done by the end of the day today. Homework 18 is to be done by the end of the day on Friday. That's the one where you're using that z-score to look up the percentiles and find percentages. Before we start looking at the review, which I do believe is posted in Blackboard, and what I'm using for a review is the old pencil and paper test that I used to give. Because when I picked questions out from my labs for the test, I tried to get questions of the same type as the ones that were in my old handwritten tests. The only difference is in the handwritten tests, you might have one set of data and 3 questions asked about that. In my lab, there won't be A, B, and C to questions. There'll be separate questions and they'll each have a different data set. Before we get started with looking at that review, does anybody want to look at any questions in any of the homeworks?
No.
No homework questions. Okay, all right, that's cool. Hopefully that means you guys are all masters of the universe and know how to do them all without help, which is always good news. All right, then I'm going to angle this a little bit so I can write on it. And in answering these questions, I'm going to ask for a lot of help from you folks. Um, First question, and you'll notice that when I used to do pencil and paper tests, I try to kind of make them a little bit local. How long have they been ranting and raving about wanting to put in a signature span for the Peace Bridge, right? So the Peace Bridge Authority wants to determine whether the residents of Buffalo support the concept of a signature span. They decide to conduct a survey of a sample of the city's residents. Which one of the following would be the most appropriate for obtaining a sample of the city's residents? To survey the occupants of every third car, there should be a quote in their car, that crosses the Peace Bridge on any given day. To hold a public hearing and survey those who attend. To survey a random sample of persons that live within each geographic region of the city. Or to place the survey on the city's website for a day for residents to respond to. Which of those sounds like it would be the best way of getting a sample?
C.
C. Beautiful. A random sample is always the best way. Next question says the annual average snowfall totals for a season in inches for 15 cities in New York State are, and then we've got the numbers given. And I ask you to make a stem and leaf diagram of the data. When you make a stem and leaf diagram of the data, doing it by hand, it's important that you give it a title. So this is the average snowfall for 15 cities. And then when we make a stem leaf diagram, does everybody remember that we're going to look at our data mostly as 2-digit data? The lowest numbers are in the 30s. The highest numbers are in the hundreds. So we have 3 for the 30s, 4 for the 40s, 5 for the 50s, 6 for the 60s, 70s, 80s, 90s. And then we'll break with tradition a little bit and put a 10 there for the numbers in the hundreds. Before I do a stem and leaf diagram, I usually do a sloppy copy because it's easiest for me to just go through and record my numbers first. And remember, for the good copy, you want those leaves in order. So the first value is a 59. Next to the 5, we'll put a 9. Then we have a 33. So next to the 3, we'll put a 3. 63, 95, 68, 103, 70, 83, 38, 64, 88, 95, 98, 76, and 100. Now, that's the sloppy copy because if you notice, there are places where the leaves are in order, and we want to make sure that the leaves are in order. So the 30s are in order. There are no 40s, so we'll leave that blank. There's a 59. Ordering the 60s, it would be first 63, then 64, then 68. The 70s are in order. The 80s are in order. The 90s are in order, but the hundreds aren't. And in my labs, that's what they're going to ask you to do, to put those leaves on. If you are doing it by hand, it's important that you put in some sort of key so that if there's somebody who's never seen a stem and leaf diagram before, they might have an idea. For that key, we'll take any of the numbers, the 3/3, and we'll let everybody know that that means 33 inches. How are you folks at doing a stem and leaf diagram?
Good.
I'm good with that.
Okay.
What is that key thing that you just put in the middle?
This is, again, in my labs, they don't ask you to do that, but if you are doing it by hand, it's a good idea. Because remember when you first looked at a stem and leaf diagram, the very first time you saw it, you didn't know what it meant. And so putting something like this, saying that 3/3 means 33, helps people read it and also gives you some idea of what place value your 2-digit numbers are. It's just going through and picking any one of the data values and saying, okay, that 3/3. In case you weren't aware, that means the number 33. And that we're doing it in inches. Okay.
Okay.
Next, you're asked to make a group frequency distribution. I have to apologize. I can't remember in my labs if it's a group frequency distribution or just a frequency distribution. But let's go over how you would do this one by hand. Since it's grouped, this is 30 to 39. The next would be 40 to 49, 50 to 59, 60 to 69, because we want our class widths to be equal, 70 to 79, 80 to 89, 90 to 99, and 100 to 109. And remember, if a question is asked, that here the class width is 10, because when I go from 30 to 40, I'm skipping 10 numbers, and so on. Now, we're just going to put in the frequency of each value. I could go up to the original values, but being that I have this stem and leaf diagram here, I think making one of those usually helps with the counting. So looking here, I have 3 numbers in the 30s. I have none in the 40s. I have 1 in the 50s, 3 in the 60s, 2 in the 70s, 2 in the 80s, 3 in the 90s, and 2 in the hundreds. Is everybody all right with making a frequency distribution?
Isn't there only 2 in the 30s?
Yeah, there are. Where did I get that 3 from? Did I say 2 and write 3, or did I say 3?
I heard 3. Sorry, I don't know.
Yeah, no, you're right. I was wrong. Thank you for catching me.
So we'll have something like this on the exam?
Yep.
Okay.
The next thing that we're going to do is we're going to make a, will be a question that asks you to make a histogram. I believe in my labs, in order to quote unquote make a histogram, it's more of a multiple choice question asking you which is the correct histogram. But let's go through the right way of making a histogram so that everybody's sure how to select the correct one. Again, we want a title. The title for this would be quiz grades.
Oh, titty.
Our horizontal axis will be our data values. So those will be the grades. Our vertical axis will be our frequency. I'm not good at horizontal writing, so I'm just going to abbreviate the frequency. Looking at this, it looks like the lowest grade's a 6 and the highest is a 10. Since I don't want to count up from 0, I'm going to put a break in the axis, and then I'll start with 6, and I'm going to space them so that there are 2 blocks between each number. It makes it easier to make my bars equal widths. And let's see, let's do our frequency up to 5, 1, 2, 3, 4, 5. I think that should be high enough. And then let's count how many 6s are there. 1, 2. So centered around the 6, I'll have a bar of height 2. Realize the 6 is the middle of my bar. And I'm going from 5.5 to 6.5 with that bar because I want my bars to touch. Next, there are 7s, and I think there are 2 7s. So there we'll have another bar of height 2. Then there's only 1 8. So above the 8, we'll have a bar of height 1. There are 1, 2, 3 9s. So above the 9, we'll have a bar of height 3. Oh, I missed a 7. Let's try that again. There are 3 7s. That's why I crossed them off so that I can tell if I missed one or not. And then there are 1, 2, 3, 4, 5 10s. So above the 10, I'll put a bar of height 5. And is everybody comfortable with both drawing a histogram or reading a histogram? Could everybody look at and recreate the data set that I'd have 2 6s, 3 7s, 1 8, 3 9s, and 5 10s?
Yeah.
Okay, great. Then next, this was, I guess, from last November, the number of goals scored by the 5 highest scoring players on the Buffalo Sabres as of last November 4th were 7 7, 6 5 4. I ask you to find the mean, median, mode, mid-range, range, and standard deviation. And again, with a question like this in my labs, they won't be all grouped together in one question, but rather you'll have a separate data set and have to find each of those separately. First of all, to find the mean, can anybody remind me, how to find the mean of a data set?
Add them all and divide it by 5.
Add them all and divide it by how many? So adding, we'll have 7 plus 7 plus 6 plus 5 plus 4. And there's 5 numbers, so we'll divide by 5. And so what does that total to?
5.8.
Well, what's the total of the numbers first?
Oh, sorry.
29, I think.
Yeah, I was like 29, and then you divide that by 5, and then 5.8.
Beautiful.
Sorry.
Great. No worries. No need to apologize. Great job. Then for the median, does everybody remember? First, we want to put them in order. And the median would be the middle of the list, year 6. The mode is a value.
Quick question, excuse me. On
Sure.
the test, what if there was, let's say there was 2 6s? We'll have to put both 6, right? Would be the
For
answer.
median, you're just going to put one number. The median is always one number. Instead, let's say there was a 3 in the front of the list. The only way the median would be different is if there's an even number of numbers. You take the middle two and find their average, add them and divide by 2. So here the median would be 5.5. So if there's 2 middle numbers, you take the average of the 2 middle numbers.
That's how I
Other-
messed up the last time. Yeah.
Yeah. Otherwise, if there's just one single value in the middle, it's that single value. Mode is the number that occurs most often. Here it would be 7. Mid-range is the highest plus the lowest divided by 2. So that would be 7 plus 4 over 2. 11 over 2 is 5.5. The mid-range is different than the range. The range is the highest minus the lowest, which would be 7 minus 4 or 3. And the range is a measure of spread. The others are all measures of center. And then for the standard deviation, when I used to give those pencil and paper tests, for the standard deviation, I would have the table made for you, and I would have the formula written. I do believe, let me just double check.
We missed the mode.
I'll be right back. I just want to double check something. For the test, I do believe that I put in, if I didn't put in, I will put it in before the end of the day, the equivalent of a formula sheet, something that would have, no, it's not in there yet. I will add that now later today and send it to you. Let me show you what it is. The formula sheet will be something that looks like this, that will have the formula for the standard deviation. And in case anybody likes using a table to set it up, I will have a table outlined there. It will have the formula for the z-score, and it will have the formula for the margin of error. And so that will be in that folder above the test if you want to take it and print it out before you take the test, because those are the formulas I would have given you on the test. Okay, now going back up to the top, I think we said what the mode was, but we didn't do a lot more about it.
Okay.
The mode is the value that occurs most often. And as I look at this data set, there's only one value that repeats, the 7. So the 7 would be the mode. So for the standard deviation, if you're using the table, the first column contains my data values, which would be 7, 7, 6, 5, 4. The second column is my mean, which is 5.8. And I like putting that column in because after I get to this point, I'm going to just work across to finish my table. The next column would be the difference, the value minus the mean. So 7 minus 5.8 would be 1.2. And when I square it, I'll get 1.44. 7 minus 5.8 is 1.2. Squared is 1.44. 6 minus 5.8 is 0.2. Squared is 0.04. 5 minus 5.8 is negative 0.8. But please remember, when I square a negative, the reason I'm squaring it is because when I square a negative, I should get a positive 0.64. And then 4 minus 5.8 is negative 1.8. And when I take that 1.8, negative 1.8 and square it, I get 3.24. It's not necessary, but I'd like to add that column of deviations because when I add them, they should add to 0. The only time they would not add to 0 is if we had to round to find our mean. Now, when I add this next column, I get, somebody check me on that. Does 6.2 look right or am I off?
Did you say 6.2?
Yeah,
I got 6.8.
6.8.
Yeah.
Yeah, that sounds a lot better. 6.8. Sorry about that.
It's okay.
I missed that 2 at the bottom when I missed something when I was adding them. 6.8. And now we haven't really used the formula too much, other than it told me to subtract, square, and add them up. But the reason I put the formula there is because it helps me remember that to find that standard deviation, we're always going to divide by 1 less than the sample size. So here, our sample size was 5. So we're going to take that 6.8 and divide it by 4. And so when I take that 6.8 and divide it by 4,
Where do we get the 6.8?
this total,
Oh, I'm sorry. I'm not myself this morning.
hey, I've made careless mistakes. It's just, we'll blame it on the weather. When I divide that by 4, I get 1.7, but I'm not quite done yet. The last thing that we have to do is we have to, which again, the formula helps me remember, take the square root of that whole thing. And so when I take the square root of 1.7, I get a standard deviation of 1.3.
So we are dividing, where's the 4 coming from?
Because there were 5 numbers, when we found the mean, we divide it by 5. For the standard deviation, we divide by 1 less than that.
That is
so
right.
4 comes from 5 minus 1. Okay. That's, in my mind, for most people, that's one of the things that's somehow is hardest to remember, that we always divide by 1 less than the number of values, 1 less than what we divided by the mean. And so that's why I put this formula here, because hopefully seeing the n minus 1 in the denominator will remind you to divide by 1 less than that.
So the n is the mean. Okay.
No, the n is the number of values.
Okay.
N is always the sample size or the number of values. In general, with statistics, X bar is the mean, S is the standard deviation when we're working with a sample, and that lowercase n is the sample size with the number of values.
Okay.
Next question deals with some of what's in that, I believe 1.7, where is it in, not 1.7, homework 17, or is it homework 16, where we're just looking for measures above and below the standard deviation. Remember, when we're looking for something below the standard deviation, it tells me to subtract. So if I'm looking for 2 standard deviations below the mean, my mean is 65. My standard deviation is 3.5. And so I'm going to take the mean. To go below, I'm going to subtract 2 times that standard deviation, which is going to give me 58. Next, when I see the word above tells me to add. So if I want 3 standard deviations above the mean, I'm going to take my mean and I'm going to add 3 times the standard deviation. And so that's going to give me 75.5. And then the next one asks for 1.5 standard deviations. It's above, so we'll add above the mean. So we'll take the mean and we'll add. And even though that's a fractional number, we're going to do the same thing. We're going to take 1.5 times that standard deviation and add it. So when I take 65 plus 1.5 times 3.5, I get 70.25.
We're
And this-
multiplying the one in the parentheses, right?
We're multiplying these two. If we want 1.5 standard deviations, that'll be 1.5 times the standard deviation. If I want 3 standard deviations, that'll be 3 times the standard deviation. If I want 2 standard deviations, that'll be 2 times the standard deviation. At some point in time in math, we stop using the x for multiplication because the x is often also used as a variable. And so when I see 2 numbers written next to each other without a symbol in between, it means that I'm multiplying.
Okay.
Next one is along those same lines, asking me to make use of my mean and standard deviation for a population. This time the mean for men is 70 inches and the standard deviation is 4 inches. First thing I'm going to do is draw a bell curve. When I draw that bell curve, when I draw that normal distribution, yikes, that's not the smoothest looking one, I'm sorry. Remember, we start in the middle. What number goes in the middle?
70.
70. It's always your mean. And then I'm going to count 3 away on each side. But when I count, what number should I count by? What number should I add on? That 4, that standard deviation. So 70 plus 4 is 74, plus 4 is 78, plus 4 is 82. And we add it when we went to the right. We'll subtract 4 when we go to the left. 70 minus 4 is 66, minus 4 is 62, minus 4 is 58. Everybody with me so far?
When do you
Yeah.
know when to stop?
We're with this graph, we're always going 3 on either side.
Okay.
And the reason that I know I'm going 3 on either side is because remember, we're going to be using that 68, 95, 99.7 rule. So we need 3 on either side because there are 3 values we're going to divvy it up by.
Okay.
Using that 68, 95, 99.7 rule, we're going to first go 1 on either, 1 above, 1 below, and we'll connect them with a box that we'll label with our 68%. Then we're going to go 1 above and below that. We'll connect those with a box that we'll label with our 95%. And then those third ones we'll connect and label with our third number, our 99.7%. The top part of that picture will always be the same. The only thing that changes are these numbers that I label on the bottom. And the middle number should always be your mean. And when I go to the right and go to the left, I should always be adding or subtracting my standard deviation. Now that we've got the picture drawn, we're going to use it to answer the questions asked. First question asks the percent of men between 70 and 74 inches. Well, if I look at between 70 and 74, do you notice that's not a full box? That's only one side of the box for 68%. So remember that line for the mean is in the middle. It should cut each in half. So we'll take that 68 and divide it by 2 to get 34%. The next asks me for the percent between 62 and 78. Well, when I go from 62 to 78, does everybody see that that's that complete grouping, that complete box for 95%? So this one, we're just going to read off the graph, 95%.
That was easy.
And now the last one asks for me for the percent below 62 inches. Below 62 inches would be this region here. Remember, we had said if it either says above or below, we're looking at outside of the box. We're looking at the rest of the population. So we'll subtract first from 100. And so that's going to be 100 minus that corresponding percent is 95, which gives me 5%. But technically, because that's everything outside of the box, that's everything on both sides. And since we only want one side, after we subtract, we'll divide by 2, because again, it's symmetric. This area should be the same as the area on the other side. Since I only want one part of it, I'll divide by 2. And so that gives me 2.5%. So if we're looking strictly above a value or strictly below a value, we're going to look for what percent that value is a boundary of. We're looking outside, so we subtract from 100. And because we're only looking on one side, we divide by 2.
And that's always the way to do it.
For above and below, yes. Then, next question, I used to think was more interesting for students rather than me giving you a random height to find the percentile. I had always thought it might be more interesting for students if they put their own height in and found the percentile. I had said that question 5 deals with a mean and standard deviation for women. Question 6 deals with the mean and standard deviation for men. So you had to pick the right ones. Right now, I'm not going to ask everybody to give me their height. So I will be brave and volunteer mine. My height, I'm 4'11", which would be 59 inches tall. And so because I'm a woman, I'm using that mean of 65 and that standard deviation of 3.5. First thing I'm going to do is I'm going to find the z-score. Remember, the z-score is the data value minus the mean divided by the standard deviation. Make sure when you do this that you subtract first before you divide. If you try to do it in your calculator all in one fell swoop, you've got to put parentheses around there. And so 59 minus 65 is -6 divided by 3.5. Gives me negative 1.7. Again, I was asked to round to the nearest 10.
Where did the 65 and the 3.5 come from? We just need to know that.
Yeah,
No. You won't have a question quite like this on the test. On the test and the question, they'll give you that information. But because I wanted to have both the information for men and women, when I wrote this test, I said, okay, if you're a woman, you're going to use the mean and standard deviation from question 5. There was the mean and standard deviation for women. And if you were a man, you were going to use the mean and standard deviation from question 6. But that would be given to you. And then when I wrote the test on my own, I only put the table in once. So to find the percentile, you have to look in the table. In my labs, the table will be built into the question. But here, because I didn't build it into the question, I just asked people to scroll to the next page. And so for a z-score of negative 1.7, my percentile is 4.46. And so that tells me that I am taller than 4.46% of women in this country.
those numbers are made up, the 3.5, right? Because on question number, was it question number 6, our answer was 2.5.
For question, what this part up here, the directions we're asking for, was to use the mean and standard deviation. So if you were a woman, you're supposed to get the mean and standard deviation from question 5. So if you look at question 5, it starts with the mean is 65 and the standard deviation is 3.5. And then if it was a man, you had to look at question 6. And question 6 starts saying that the mean for men is 70 and the standard deviation is 4. So all I was looking for people to do with that question was to take the mean and standard deviation. But again, on the test, because it's a MyLabs question, and each question you won't have to refer back, they will tell you the mean and the standard deviation. Then next question deals with what we did last class. Last class, we talked about the margin of error. And remember, for the margin of error, what we needed was the sample size. And so N is the sample size, which is here 3,000. So the margin of error is 1 over the square root of the sample size times 100 to change it into a percent. And so if I take 1 and divide it by the square root of 3,000, and then multiply that by 100, to the nearest 10th, I would get 1.8%. On the pencil and paper test, I asked people to write their own statement. In my labs, it's more of a fill in the blank. So in my labs, it'll say that we are 95% confident that between, and in my labs, there's 2 blanks that you have to fill in, of Americans work from home during COVID. And does everybody remember In order to fill in those blanks, to get those values in between, I take the percent and I add and subtract the margin of error. So this first one would be the value that I get taking 62 minus 1.8, which would give me 60.2%. And the second one will be the 62 plus the 1.8, which would give me 63.8%. And again, the purpose of that is because for these 3,000 people that we surveyed, it was exactly 62%. But we're generalizing it to way much more than 3,000 people if we're looking at it as all Americans. And so because we're generalizing, it's not going to be exactly 62, but somewhere near 62. How near? Our margin of error says it can be 1.8% above and below. And so that tells us that while it won't be exactly 62, it'll be near 62. Probably 95% of the time, it should be between 60.2 and 63.8%. Is that margin of error question all right?
Yeah.
Then the last question asks us to use z-scores to find percentages above and below certain values. Here we're looking at IQ tests that's normally distributed with a mean of 100 and a standard deviation of 16. The formula tells us that the z-score is the value minus the mean over the standard deviation. And what we have to remember is that the percentile means the percent below. And so if I want the percent below 112, I'm just going to find the percentile. My z-score is that value minus my mean divided by my standard deviation, which gives me my value is 112, my mean is 100, my standard deviation is 16. So that gives me 12 over 16, which is 0.75. And so now I'm going to use the table for a z-score of 0.75. I get the 77.34 percentile. So that's going to be 77.34%. Next question asks for the percent above. For the percent above, it's the rest of the distribution. So it'll be 100 minus the percentile. So first we have to find the percentile. To find the percentile, I need the z-score. The z-score is the data value. Here that's 92 minus the mean. For this question, we know that's 100 over the standard deviation. For this question, we know that's 16. So that gives me negative 8 over 16, which is negative 0.5. Think on the table, that would be negative 0.50. And so negative 0.50 is the 30.85 percentile. And so for the percent above, we'll take 100 minus the 30.85, which will give me 69.15%. And then the last thing you need to remember is if I'm looking for the percent between two values, I subtract the percentiles. The percentile for 110 was 77.34 minus the percentile for 92 was the 30.85. And so when I do that subtraction, the 77.34 minus the 30.85, I get 46.49%. Again, it's not necessary, but I know that in a statistics class, it's strongly recommended that when you do something like this, you draw it on a normal curve. And so the first one, 116, the percent below was 77.34%. The second one, the 92, was below the middle. The percent below was 30.85. And so when we subtract from 100, we get that the percent above is the 69.15. And then for the last one, if you look at it in the normal distribution, for 116, we get that it's 77.34% below. For 92, we get that it's 30.85% below. And so in between would be the difference we'd have to subtract. Which I don't know if those diagrams of the normal curve helps you picture why we subtract 100 and why we take the difference. But in a statistics class, they usually ask that you do that. So. And just as we get to the last minute of class, we've finished that last question. Does anybody have questions about any of these? If not, I'm going to stop sharing and stop recording.